Hi all, welcome to i-tutor Academy. In today's session, we will start with the Unit 14, Subsession 5 of Mmpc 009. It's the last class of Mmpc 009. And tomorrow we will start Mmpc 010. And in between any doubts of Mmpc 009, please comment it on our comment box, or you can contact our contact number also. Okay, so let's begin. The functional classification of waste management. So that is the subsection of 14.5. The problem associated with the management of waste in today's society are complex and diverse in nature. For an effective and orderly management of waste, the fundamental aspect and relationship must be identified and clearly understood. And the efficient waste management comprises of the quick identification of the waste generated or caused, economic reduction, efficient collection and handling, optimal reuse and recycling, and efficient disposal of waste, leaving no environmental problem. And waste management can thus be functionally classified into five basic elements, that is generation, reduction, collection, recycling and disposal. However, waste management should be viewed in totality, considering the interrelationship of basic functional elements system as shown in figure. So here is figure. Okay, so this is functional element of waste management. And one of the objective of waste management is to optimize this basic functional system to provide the most efficient and economic solution commensurate with the constraint imposed. By considering each element separately, it is possible to identify the fundamental aspect and relationship involved in each element and develop, wherever possible, quantifiable relationship for the purpose of making engineering comparison, analysis and evaluation. Okay, so please refer this figure from your Igno study material Mmpc 009, so you will get more idea. Okay, generation of waste. And there may be numerous causes responsible for the generation of waste in different system, and however some general causes of waste generation at a different stage had been perceived, and the checklist of cause of waste generation is shown in table 1. So this is one checklist of causes of generation of waste, and it is possible to account for the amount of waste generated against respective cause. Then the most critical cause will be one that contribute to the highest aggregate cost of the waste. This is ineffective policies, lack of planning, political pressure, defective organizational structure, more emphasis on subsystem objectives rather than organizational goals, poor management, faulty system and procedure, personal interest, careless and neglect, lack of individual responsibility, and non-acquiescence with the latest technological development, resistance to adopt automation and computerization, and wrongly laid down design standards, lack of standardization and codification, wrong choice of raw material, ignorance of inventory control and inappropriate storage of facilities, poor handling of material, poor layout of facilities, information delayed. So this is 35 numbers, of 35 numbers are there checklist, so please go one by one. And technology also there, insufficient skills and lack of motivation, improper recruitment. So please go one by one, you will get an idea. And accurate information on waste generation rates and the composition provides a basis for the design and operation of various waste control programs, recycling and processing plant, waste disposal projects, and choice of most effective disposal alternative. And the problems in obtaining the information on this aspect are complex and involve following factors. And various establishments may differ widely in their waste generation practices. Most firms are reluctant to reveal production and related statistics for fear of the data being used to the competitive advantage of others. Generally, the firms are reluctant to provide information on quantity and composition of waste or fear of it indicating non-compliance with the pollution control regulation. The quantum of waste generated reflects the inefficiency of the organization, and some industrial activities are subjected to seasonal variations, and the extent of salvaging, recycling or other reclamation of waste differ greatly among manufacturers, and many firms themselves have little understanding of and few records on this aspect. And a systematic approach to waste reduction, or a systematic approach to minimize the total system waste, minimizing the waste at the individual stage in conjunction with the other stage, has become proposed in figure. So this is figure stage wise waste reduction and a systematic approach. Okay, so please refer this from your ignore study material also. And it provide a scientific and a systematic method for waste reduction at the individual stage, and finally for the whole system, the procedure for approaching from all to part and then from part to whole is proposed. The basic steps of approaches are: recognize the waste for all system, identify the stages at which waste is caused or generated, and visualize the whole waste into fractions caused at various stages as identified in steps, and apply the systematic waste reduction procedure at each stage separately. That is, recognize the waste, identify the cause, plan corrective action, and eliminate the cause, and find the correlation of various stages to assess the effect on waste generation at one stage due to waste reduction at the other stage. And if there is no such a correlation, then establish control separately at each stage to prevent recurrence of the cause of waste generation. And if such a correlations exist and waste is caused, then find the stage affected, and try to obtain a break even of waste at the related stages so as to minimize the total aggregate waste at all the stages, and establish control to prevent recurrence of the cause of waste generation. And the waste management system for individual organizations, sectors, as well as the whole economy should be designed to fulfill the goal of zero waste. Zero waste should not be misinterpreted at if no waste is generated. Such an interpretation will be neither feasible nor justified, as some waste is inevitable with the function of any system. A 100% efficient system is only hypothetical, and further, such a system will be closed and will have a zero growth rate, which is not desirable. The main theme of the philosophy of zero waste is to waste is to that is first of all, try to minimize the waste generated as far as it be technologically and economically feasible, and whatsoever little waste is generated should be put to some effective use. And the goal of zero waste should be visualized from system point of view, and to have zero waste of all types of resources simultaneously. Otherwise it may be futile to aim towards zero waste for one type of resource if it causes the waste of another type of resource. And next is waste collection system. Waste collection has got a significant effect on subsequent functional elements, that is public health, aesthetic, housekeeping, and public attitude concerning the operation of the system, as collection and transportation constitute a major cost in waste treatment, and the streamlining of collection techniques can greatly improve the efficiency and effect a significant saving in the overall cost of waste management. This will be beneficial in two ways, that is, reduce disposal effort and advantage of resource recovery by effective recycling of waste. The proposed strategies for waste collection are: design of economic basis to facilitate separation at a source, to provide every organization with a set of 4 standard bins to separately collect the metallic, plastic, paper, and other miscellaneous waste. The bin should be designed after careful investigation of the type and quantum of waste generation generated, and design of appropriate collection system governed by public or private agencies to regularly collect the segregated waste at time intervals depending upon the generation rate, and incentives to encourage segregation of the waste at source, and timely collection of scrapped organization appliance along with the segregated waste and its flow through salvage industry for ultimate reuse, and the development of appropriate collection system for the collection of miscellaneous organic and inorganic waste. Next is recycling of waste. In the absence of conservation or recycling, certain of the world's finite resources will diminish to a level incapable of maintaining an acceptable environment and adequate life support. Unfortunately, in India, there is a growing awareness to recycle or reuse the waste, and the National Committee on Science and Technology has identified a number of recycling projects, and the term recycling, reuse, reclamation and recovery have different interpretation, though these terms are generally used as synonyms. And in this study, the term recycling is adopted to mean all these terms. And recycling generally refers to the use of undesirable output or waste as input to the same process or system. And recycling of foundry scrap reuse may be termed as the use of waste generated from one process or system as input to some other process system as raw material, or for the generation of power or byproducts. And the conversion of damaged, rejected and undesirable output into the desirable output by repair of processing is termed as reclamation. And the term recovery is utilized to denote the gain of resources from the waste. And the recent development of recycling of waste in our country have been noted with concern. And New Jersey for the players of cricket and football is being prepared from the used water bottles, that is Star India. And plastic, that is sieve made from the damaged and rejected polyethylene bags for separating coarse grains from the fine one are under circulation for domestic use. And the great achievement is made by manufacturing composite colored wall title with the help of nanotechnology by using old tattered carpet based and worn and torn doormats. These tiles are heat and sound resistant. Environmental friendly writing papers are being prepared from the recycled plastic bag, chappals, and containers. And the flowers and other puja materials after performing the ritual from the place of worship like a temple are recycled for making agarbattis, dupattis, and artificial leather. And great progress has been made to make building from flash bricks and highway with the plastic waste and rubber combined. The list does not stop here, and many more such innovating ideas are taking concrete shape regularly in India to make the planet Earth lovely and eco-friendly place to live in. And waste disposal system, this element link the waste management system with the environment and other system and has got a significant impact on the same. And the adoption of poor disposal practices have resulted in severe environmental pollution in different part of the world, and particularly in the big industrial centers, and have posed serious threat to human life. Some of the developed countries have taken the problem on war footing and have started developing and adopting latest technology in this regard. And in India, the awareness has grown recently, and the design of effective waste disposal system has become a challenging problem area. And from disposal point of view, waste may be categorized into salvable waste and non-salvable waste. And the waste that have got some salvage value are termed as salvable waste. Okay. And the scrap, rejected good, surplus, obsolete items and equipment, etc., fall under this category. And the well designed disposal system for salvable waste may provide best return to the organization, contribute to cost reduction and higher profit, and aid to material conservation. And the waste which do not have any salvage value but need further processing and treatment for disposal are termed as non-salvable waste. And the non-salvable waste are primarily responsible environmental hazards, and proper management of waste may amount to resource recovery and reduce environment and other social costs. Guideline for disposal of salvable waste. The salvable waste, example scrap, surplus, obsolete stores and equipment, unserviceable appliances and machinery, abandoned vehicle, etc., is generated in almost all sort of manufacturing and service providing establishments. Okay, next is the procedure for the disposal of different type of salvable waste vary from situation to situation, and some broad guidelines have been suggested to aid the design of system and procedure for disposal in individual case. That is, first of all, the feasibility of recycling should be analyzed to dispose the scrap. Try to use the scrap for producing byproduct, and try to transfer the surplus from one department to another or to other plants in case of multi-plant organization, and analyze the feasibility to sell the scrap as raw material to other plants, and to sell the scrap surplus to external export agencies dealing with it, and selling of scrap through advertisement and auctioning. And the frequency of auctioning should be decided after analyzing the generation rates and by obtaining a break even between the scrap or surplus carrying cost and auctioning cost, and selling the surplus in open market or to the employees itself, and particularly in case of consumer, if the product is not meeting the quality requirement, then classify it as second and give a discount. This may act as incentive to employees, and to consult the vendor and return the surplus to vendor, and to sell surplus or obsolete equipment through advertisement and invite the offers from other parties. And in case of damaged equipment, try to sell the parts after classifying into the categories of good, serviceable, repairable, or reclaimable, and scrap. To donate the rejected material to charitable organization to gain socio-economic respect. And processing and disposal technique used for non-salvable waste, that is, processing technique are used in solid waste management system to improve the efficiency of operation, to reduce storage requirement, facilitate disposal to recover resources, conservation product and energy, and to minimize harmful environmental effects. Disposal is the no alternative option and the ultimate fate of all waste that are of no further value. And various alternative processing disposal technique have been briefly discussed as follows. This is mechanical processing. Under this, there is compaction, baling and shredding, component separation, and thermal processing. Under thermal process, this is the mechanical processing. Okay, so next is thermal processing. The thermal processing of waste result in volume reduction, generation of energy, and byproduct. So the overall heat content of solid waste, including moisture and ash, etc., is approximately 10.5 million BTU per ton, which is most nearly comparable to that of low rank lignates. And under this, that is incineration and high temperature oxidation of the organic and toxic compounds present in gaseous waste is employed to destroy the offensive effluent and odors by converting them into harmless gases, that is oxygen and waste vapor. Next is pyrolysis. The pyrolysis of solid waste strictly refers to the destructive distillation or the thermal decomposition of the waste in an inert atmosphere. Next is bioprocessing. For bioprocessing, under there is composting, ultimate disposal, and sanitary landfilling. Okay. Next is design effective waste disposal system. The design of effective waste disposal system is an important aspect of waste management, and the system should be designed to promote the maximum possible recycling or reuse of waste and for minimum environmental hazards. The flow diagram of waste disposal system has been shown in this figure. Here is one more figure. This is flow of diagram of disposal. Okay, so please refer this and use your study material for analysis of this diagram. And various factors that should be considered in the design of waste disposal system are: public attitude is there, regional national policies, economic consideration, land availability, and equipment requirement, groundwater protection, environmental control, fire prevention, litter control, operational plans, employer facility, equipment maintenance, and operational recovery. So these are the things considered for the waste disposal. And the next is outline of IOW, that is input output waste model. It has been visualized that it is possible to take waste as an explicit parameter, and existing input output model can be modified to incorporate waste management constraint. And to provide closer representation of real life system, it is proposed to remodel them in the framework of an IOW, input output waste model. And the proposed model will be able to define the resource balance more realistically by incorporating the reduction, recycling, abatement, disposal, and related function of waste management. And the IOW physical system define the resource constraint for every viable system as the balancing of input to the sum of output and waste for each type of resource. That is, input is equal to output plus waste. And basic framework, the basic framework of IOW model define IOW flow metrics and IOW coefficient metrics and consistency equations. And the IOW flow metrics consist of a set of convention, intermediate, demand or resource flow metrics extended to include waste management sectors, final demand metrics plus added waste flow metrics, and an aggregate IOW metrics is shown in this table. So here is intermediate demand or resource flow metrics, that is input of resource. Final demand metrics, that is total final demand is here. So total output is here. Okay. And coefficient metrics also here. Okay. So the model may be generalized for n production sector and m waste management sector. And the source of primary input are aggregated as trade, habitat, and nature, whereas the final demand is clubbed into domestic consumption, trade, and change of stocks. The intersectoral waste flow is treated as an intermediate waste, while final waste include waste recycled in habitat by changing lifestyle, waste disposal of by trade, and the waste ultimately disposed of to nature. And the treatment of wastage in cost account. It is realistic to expect that all material put into process will not end up as good sellable product, and some loss, scrap, and wastage are inevitable in process industry, and the losses must be computed in advance before the processing options begins. The process loss can be divided into two categories. One is normal loss and one is abnormal loss. Normal loss is the loss which is unavoidable, uncontrollable, and expected in normal condition. It may be inherited in the manufacturing process. If the loss is inevitable, unavoidable, and within the limit, it is called a normal process loss. That is, abnormal process loss is controlled and generally caused by abnormal or unexpected conditions such as bad designing, poor material, accidental and negligence, etc. And the treatment of normal and abnormal losses differ in process accounts. And the following procedure will help in preparation of process cost account that do not present any difficulty. And normal loss should be computed on the basis of information given in the question, and the cost per unit of production after taking into account normal loss unit should be determined, assuming that abnormal loss does not exist. And the cost per unit is calculated on the basis of the following information. One is normal production, one is normal cost of production. And normal cost of production divided by normal production will given the cost per unit. And the cost per unit determined as above is used to value abnormal loss unit, and that would be the cost of abnormal loss. And the abnormal loss account is debited and the relevant process credited with the amount and quantity of abnormal loss as calculated in above. This one. Okay. And the cost per unit as obtained in 3 will also be applied to determine the cost of good production unit produces by the process. And the process proceeds realized from the sale of normal loss representing scrap, that is if any, is transferred to the relevant process account. And the processed proceeds realized from the sale of abnormal loss representing scrap is transferred to a separate abnormal loss account and not to the relevant process account. The abnormal loss account is closed by transferring the total cost of a abnormal loss unit to the costing profit and loss account if there is no scrap. In case abnormal loss represents scrap only, the net amount, that is total cost of abnormal loss unit minus scrap, that will be transferred to the costing profit and loss account. And next is concluding remark. The problem of waste management should be visualized in a broader perspective, and an organized system approach to waste management should be adopted. And it is unfortunate that despite the cruciality of waste management in socio-economic resource structure, in its ecological and environmental compatibility, it has been ignored most of the time. And there is a need to standardize the taxonomy of the waste and no critical analysis the functional element of waste management is a dynamically emerging field with vast scope, and though awareness awareness in this field is growing slowly, and if proper attention is paid, it may rapidly gain momentum. To accelerate the effort to achieve universal sanitation coverage and to put the focus on cleanliness, government of India has launched Swachh Bharat Abhiyan on 2nd October 2014 on birthday of Mahatma Gandhi to effectively handle the waste management. And summary of this unit is here. So in this unit we have proposed a new enlarged concept of waste and wastivity. The best way of waste management is not to generate waste at all, and a preventive policy of waste generation is advocated. So we have established the close relationship between wastivity, productivity and resource management. A 7-step systematic approach has been given for waste reduction. Guidelines for waste collection, recycling and disposal have been discussed, and some processing and disposal system have also been overviewed. A brief outline of an input-output waste model has been given, and it is difficult to accurately account for all wastage. Yet another procedure has been suggested that will help in the preparation of appropriate cost account. And keyword section also here. If you feel any words are difficult, you will get their explanation. And self-assessment exercise is here. Total 9 questions are here. Please do it. It will help you for your term and examination. And like your assignment, it is also important. In between any doubts, you can contact us anytime. And so this is all about Mmpc 009, and that's it, today's class. And more MBA series, you just do like, share and subscribe our channel. Thank you so much.
i-tutor Academy presents Ignoumba MBA complete syllabus coverage classes for individual students, semester-wise subject with online and flexible timing. For more details, contact on +916 238 217 885.